So I'm really excited about this video where we'll look at how to find the inverse of a matrix. From our question here, gotten from the introductory video, we will notice that this is not just any matrix. It is a square matrix and a 3 by 3 matrix. So by watching this video, you will learn how to find the inverse of any 3 by 3 matrix. Now there's a basic formula I would like to highlight first. When given a certain matrix B as this, the inverse of B is 1 divided by the determinant of B multiplied by the adjugate of matrix B. So let's start by finding the determinant of matrix B. Now the first step, you see the square braces, let's take them off like this. Then let's take the first 2 columns in the matrix and replicate them here like this. You'll notice that I did not change the arrangement, I just replicated them the way they are. Now starting from the first number on the first column here, which is 3, I'm going to draw a bubble around the diagonal it creates going downwards like this. Then I multiply the numbers in this bubble. 3 times 9 times minus 1 is equal to minus 27. So I place it here. Then I move to the first number on the second column here. I draw a bubble around the diagonal it forms when we go downwards, and I multiply the numbers here. 0 times 4 times minus 2 is 0, so I write it down here. Finally, I move to the first number on the third column, which is 2. We also extend our diagonal downwards and draw a bubble. We multiply the numbers in this bubble. 2 times minus 6 times minus 1, which is 12, so we place it here. Now with a fresh sheet, I start from the last number on the first column, minus 2 in this case. I draw a bubble around the diagonal going upwards. Then I multiply the values here. Minus 2 times 9 times 2 is minus 36, so I place it here. Then I move to the last value on the second column. I also extend my diagonal going upwards and I draw a bubble around it. When I multiply these values, minus 1 times 4 times 3, I should get minus 12, which I place here. Then moving to the final value on the third column, which is minus 1, I also draw the final diagonal going upwards this way. So when we multiply these numbers, minus 1 times minus 6 times 0, we should get 0, which I will place here. Now if I bring all my bubbles together this way and what the product of each one gave, we should have something like this. Now this is what we do with these numbers. We take the numbers below in red, which are minus 27, 0 and 12, and add them together. So when we add this up, we should get negative 15. We take the numbers above in blue, minus 36, minus 12 and 0, and also add them together. When we do this, we should get minus 48. So we take minus 15 and minus 48 and subtract them. So basically we are subtracting the sum of the numbers in blue from the sum of the numbers in red, and we'll get 33. Therefore the determinant of matrix B is 33. So we can rewrite our formula for the inverse of matrix B this way, since we just found the determinant to be 33. Now how do we find the adjugate of a 3 by 3 matrix? The first step is to write out our original matrix and also draw out a larger 3 by 3 matrix where instead of values you put boxes. Now let's see why we have all these. We are going to perform a very simple elimination process, and this is how it goes. First, you circle the first value on the matrix to eliminate it. In this case, we circled 3. Then you extend lines to cross out the values of the row and column on which 3 lies, this way. Now you see the values we have here, 9, 4, negative 1 and negative 1. We replicate it as a 2 by 2 matrix here. As you can see, we placed this 2 by 2 matrix on the exact same position as the first number we eliminated here, which is 3. So 3 is occupying the first position here, so is the matrix occupying the first position in this larger one. Now going from left to right, we circle the next value, which is 0, to eliminate it. Then you extend lines to cross out the values on the row and column of which 0 lies. So we have minus 6, 4, minus 2 and minus 1 left. So we replicate that as a 2 by 2 matrix here. We continue this way for 2. We circle 2 to eliminate it. Then we also extend lines going across the row and column on which 2 lies. We have minus 6, 9, minus 2 and minus 1 left, so we replicate that here. We move to minus 6. We extend lines to eliminate the values on its row and column. We have 0, 2, negative 1 and negative 1 left, so we write that here as a 2 by 2 matrix. We move on to 9. We also extend lines to cross out the row and column, and we have 3, 2, negative 2 and negative 1 left in this order, so we write that as a 2 by 2 matrix. We move on to 4. We extend lines going across the row and column. Then we have 3, 0, minus 2 and minus 1 left, so we write that here. We move then to minus 2. We extend lines across the row and column on which minus 2 lies. Then we have 0, 2, 9 and 4 left, so we write that here as a 2 by 2 matrix. We move on to minus 1. We also extend lines similarly, and we have 3, 2, negative 6 and 4 left, so we write that as a 2 by 2 matrix here. Then finally, we also go to the last number minus 1. We extend lines the same way, and we have 3, 0, minus 6 and 9 left, so we write that as a 2 by 2 matrix here. Now at this point, we have to find the determinants of all these 2 by 2 matrices that we have here. So let's begin with this one. We use the normal procedure for finding the determinant of any 2 by 2 matrix. So we take our leading diagonal, 9 and minus 1, we multiply the values. Then we take the second diagonal, 4 and minus 1, multiply the values, then we subtract them. We do this for the next one. We take minus 6 and minus 1, multiply to get 6. Then minus 2 and 4, we multiply to get minus 8. Then we subtract this. Then we move to the next one. We multiply minus 6 and minus 1. We get 6 from that. We multiply minus 2 and 9 to get minus 18. Then we subtract that to place here. We continue this way for the next one. We multiply the values on the leading diagonal, multiply the values on the second diagonal, and subtract them to place here. We move to the next one. We do the same. We multiply the values 3 and minus 1. We also multiply the values minus 2 and 2, and we subtract to place here. We do the same here. We multiply the values on the leading diagonal and the second diagonal, and we place here. The values on the leading diagonal are the values highlighted in red, going from the top left to the bottom right. So we take the values on the leading diagonal for this one, we multiply them, that gives us 0. We take the values here, 9 and 2, multiply them, so we'll have 0 minus 18. For the next one, we take these values, 3 times 4, multiply them. We take the values minus 6 and 2, multiply them, so that should give 12 minus 12. Then we take these values and multiply them. We also multiply these ones and subtract them to place here. So now that we have this, we are going to subtract all these values. We are just going to simplify them. If you have any problem doing this, I'm going to leave a link to the video at the top right corner so that you can watch it. It's very comprehensive for adding and subtracting positive and negative numbers. So when we subtract all this, we should arrive at this. So at this point, we are going to alternate positive and negative signs. What this means is that we are going to place a positive sign on the first number, then a negative sign on the next number, then a positive sign on the next number. We continue with a negative sign, positive sign, negative sign, positive sign, negative sign, and finally a positive sign. Now, what do we do with these signs? We actually use them to multiply the numbers on which they are above. For instance, plus is above minus 5, so we use this plus sign to multiply minus 5, and that still gives us minus 5. Minus is above 14, so we multiply 14 with the negative sign, and that gives us negative 14. Plus is above 24, minus is above minus 3, so when we multiply minus by negative 3, we get plus 3. So when we simplify all this, multiplying the signs by the numbers, we should arrive at this. Now we have come to the stage of reflection. So you see this main diagonal right here. I'll highlight the boxes so that they become more visible. We are going to reflect our matrix along these lines. This means that we are going to switch values on the opposite side. For instance, minus 2 and minus 14 are on opposite sides. Minus 18 and minus and 24 are on opposite sides. Minus 24 and 3 are also on opposite sides. So I'm going to highlight them so that you see them more clearly. The numbers with similar colors are on opposite sides. So for instance, minus 2 and minus 14, we switch them like this. So we have minus 2 replacing minus 14 and minus 14 replacing minus 2. Minus 18 and 24, we also switch their positions like this. 3 and minus 24, we switch them like this. Therefore, the long-awaited aggregate of matrix B is given as this. Now, using our formula, we find the inverse of matrix B. So we take 1 divided by the determinant of matrix B, which is 33 in this case, and multiply with the entire matrix. What this implies is that we multiply every single value in the matrix by 1 over 33. So we take 1 over 33, use it to multiply minus 5, 1 over 33, use it to multiply 1, 1 over 33, use it to multiply minus 14. We do this for every single value in this matrix. So with that, we should arrive at something like this. And if you notice, some of these fractions are not reduced to their lowest terms. For instance, minus 18 over 33 can be further reduced, and so can minus 24 over 33 with some other numbers here. So we reduce them to their lowest terms, and we have this as the inverse of matrix B. So that's all for the inverse of a 3 by 3 matrix.